Welcome back to my channel, everyone. Three tips here. I've got some gold boiling in nitric acid here. This is gold that's been incorporated with silver. What we're going to do is pour off this nitric now into my silver jar over here. This has got sterling silver pieces in it, and what I want to do is get all of the nitric consumed that I can by pouring it into this silver jar. Here we go. This is boiling nitric acid, and we're pouring it out into this silver jar onto pieces of sterling silver here. You'll notice that we get an immediate reaction as the hot nitric acid dissolves the silver. Just burn a hole through the plate there. Almost got it all out of there. And again, what this does is this consumes that nitric out of my reaction beaker there. I think this is the third or fourth nitric boil on this batch of gold. This was imported gold, carat scrap that I had. Rinse all that blue color off of there. So we'll set it back down here, and I'm gonna add some water to it. Distilled water going in. Now I'm gonna put some nitric acid in here. I think this is the fifth boil, nitric acid boil. And what we're trying to do is get all the silver that we added back out of here, and any of the other silver and base metals that was already in the carat scrap. Try to get this back out of the gold and purify it. Now we're going to set it back up on the heat here. As you can see, that nitric acid, that hot nitric, made quick work of that sterling silver dish that was in that silver jar there. Ate a hole right through it. I'm shifting gears on you here now. I'm over at the silver cell. This is the power supply for my electrolytic silver cell. If you look down here, this is the impure silver crystal from my last batch, and what I'm doing is I'm running it through the silver cell a second time. You can see the silver collapses when I push it down in there because it's being dissolved by the electrolyte. And so what we're going to do now is put some more silver crystals into the cell here. Alright, if you look up here at the power supply, now the amps have gone way back up because I've got a whole lot more silver down in the bottom of the anode filter making contact with the electrolyte. This is about 2 days growth. Let's see, what is day? Today's Thursday, and I started this on Monday, so that's 3 days worth of growth down in the electrolytic silver cell. This is pure silver crystal that was discolored. If you remember from a previous video, what I did is I restarted the cell and I fed this pure silver crystal back into the cell to refine it a second time. And once all this gets used up, I'm still going to have plenty of room in here. So what I'll do is I'll just keep feeding pure silver crystal into the cell until we get a nice big batch of double refined pure silver crystal. And then we'll offer some of that for sale on my eBay store. This is our 5th nitric boil. Solution is colorless. No more fumes. That tells me that this nitric boil is complete. So what we're going to do is take it off the heat. And I'm going to save the used acid for a future refining. Alright, now we'll rinse the gold off and add the rinses up here to the silver jar, because this rinse water will contain a little bit of nitric acid. Just add it right into our silver jar. If a little bit of gold goes in there, that's fine, because we'll filter that silver solution out later on and save the filter, capture the gold later on. This is about 1.5 tray ounces of gold. I'm adding some hydrochloric acid to the gold now. We're going to begin to dissolve it. I'm going to add about 150 milliliters of hydrochloric acid here. I'm going to add a little bit of concentrated sulfuric acid here, about 3/4 of a milliliter. And what that'll do is that'll precipitate out any lead that may be present. Let's cover this thing back up. I've got some concentrated nitric acid here. What we'll do, that's about 1.5 ounces in there. We're going to add about 3 droppers full. To start with, that's 3. Let's go to 4 and 5. One more, 6. That's 18 milliliters of concentrated nitric acid. Now let's put this up on the heat and let this react now. I think we've got it all in solution now. If you look under here, all I see is a little bit of silver chloride. So what we're going to do now is take this down off the heat and just let this cool down. This is the jeweler's buffing wheel, and what we do is we take our item that we want to buff and we buff it. And when we do, if you notice on my finger right there, there's some gold dust in that material right there on my finger. After we get done buffing the piece, we bring it over here and we put it in the ultrasonic, and I kind of use the solution in here to get all that gold dust off of my fingers while I'm over here. What happens is the piece of jewelry will have some gold dust on it along with that buffing compound, and it settles down to the bottom of the ultrasonic cleaner. And every day, the jeweler empties out the ultrasonic cleaner into one of 3 5-gallon buckets. This is the residue from the ultrasonic from yesterday. It's being allowed to settle. And this is today's fresh pour off. And what we'll do is allow this one to settle. And here in the bottom of this bucket is, I don't know how many years worth of accumulation of the gold dust from the jeweler's ultrasonic cleaner. And this is the material we're going to be working with today. Here's the gold that we were dissolving. As you can see, there's still plenty of gold that must be dissolved. And yesterday I concluded incorrectly that all of it had dissolved because I was adding extra nitric and I was getting no reaction. This is a good teaching point here. I incorrectly concluded that all the gold had dissolved when clearly you can see it has not. And the reason it didn't dissolve and I was adding nitric and nothing was happening is because I did not have enough hydrochloric acid in here. So I'm adding hydrochloric acid. I checked my records, there's about 2 troy ounces of gold in here. See, look at it take off. Just from adding the hydrochloric acid, now I'm getting a reaction in here. And that's important to understand, because if I'd have kept charging, putting nitric in there to try to get that gold dissolved, nothing would have happened, because all the available hydrochloric had been consumed by the reaction. And so to a novice refiner who's not experienced, it would be easy to conclude that you need to add more nitric in there to get it to go into solution. Then you'd end up with a whole bunch of excess nitric in here, when in fact what we actually needed was more hydrochloric acid. So now we're going to set this back up on the heat and let this continue to dissolve to get the rest of the gold to go into solution. Here we go. This is 10 minutes later. All I've added is hydrochloric acid. I didn't add any more nitric. There was already enough nitric in there to get this to dissolve completely. That's an important lesson here. I was shy on the amount of hydrochloric acid that I had added, and the reaction stalled because there wasn't enough hydrochloric acid. If I'd have sat there and started pumping a bunch of nitric in there, I'd have a whole bunch of excess nitric in there now. So we're going to pull this down, let it cool off, and go from here. Now we're going to filter the solution. I've cooled it off with some ice cubes. Change to a fresh filter flask, and then we'll pull the solution back through the filter a second time through the same filter and try to get our solution to clear up. You see it's a little bit cloudy. I want to pull it through the filter a second time. Here we go. Here's the junk in the filter. Now what we'll do is transfer the solution to a beaker. Got a beaker full of ice made with distilled water. Solution's a little clearer now. Not crystal clear, but the second pass through the filter a second time cleared it up nicely for us. We'll do this first precipitation with sodium metabisulfite. Here we go. First spoon of sodium metabisulfite going in right now. There's our white foam. I think we're done now. One more spoon just for good measure. All right, I think we're done. Here I'm setting up to do an experiment. One of my viewers commented in the comment section of the last video, suggested, it was a chief warrant officer for the Navy. He suggested that I go ahead and cast a silver bar directly, cast a wire directly into the bar. And you got to remember here, I'm operating the camera and trying to perform the task at the same time. And when I shut down the time lapse here, I
I pressed the button for the camera to start and missed the shot of the pour because it didn't start when I pressed the button. So we missed the pour, but as you can see, the experiment was a success. I did get the silver bar cast with a wire right in it, and that'll eliminate that connection down by the silver cell. That was a good idea. I'll perfect this method and start using this type of anode.
I've got the wire soldered right into the bar. If you look, the wire did melt a little bit down there when I was pouring it, but that's okay. I think we're going to try this now. This is my prototype. I spent a better part of 20 minutes looking up who made the suggestion, and I found the chief warrant officer. His name was Daryl Daniels, and I'd like to give a little shout out to Daryl for making this suggestion of eliminating the clip completely from the circuit. I'm going to kill the power supply. I fashioned a little hook on the end of this so it'll fit. Now what we'll do is put the new anode bar into the anode filter here. Be a little trial and error process here with this new configuration. I've got some silver crystal here. I'm going to fill the basket back up. Here we go, moment of truth. I have no doubt that this will work. It's a straight connection now with that wire cast right into the anode bar there. Let's go ahead and turn our power supply on and see what kind of reading we get here. Ha, look at that voltage changed. I may have hit the adjustment on here when I was installing the new cable. I'm going to put it back to 3.7. Alright, let's do a test here and see what kind of voltage we're getting right down at the cell. Holy cow, look at that, man. It's the same as up here on the power supply now. Wow, that was a huge improvement. I'm going to turn this back down to 3.5 now. That was a huge improvement and a very beneficial suggestion by Daryl Daniels. Man, that's just a huge improvement. Just goes to show you how important it is to pay attention to these comments in here. Okay, we got 3.5 volts at the cell also. I'm on the anode bar up here, and then I'm touching the actual bowl, the electrode, and I'm back down to 3.2 volts. So that means these clips on here aren't transmitting, aren't conducting the electricity properly to the bowl. That was on the clip. I'm only getting 3.2 volts on the bowl, so I'm going to adjust the voltage back up to 3.7, and then we're going to retake the reading down here on the cell. This leads on the anode bar, this leads on the stainless steel bowl. We're back up to almost 3.4. So I'm going to leave that voltage adjusted to 3.7, and then we'll rethink the harness here going to the cell and try to improve the connection there. Here you can see the conductivity's way up there, almost 2.5 amps at 3.7 volts. I just wanted to give you a quick look inside the cell here. Today is Saturday, so this thing's been running for about 5 days now. I started it on Monday. There's the look at the pure silver crystal in the silver cell. Here's our pure gold powder from the first precipitation. Notice that it's kind of dark brown color, which indicates that we have a little bit of contamination possibly in our gold. So I'm going to pour off this waste solution now. Now what we'll do is rinse it off a little bit with some hydrochloric acid. I'm going to rinse it with a little distilled water. See if we can get the chemicals off there best we can. Now we're going to add some hydrochloric acid, about 200 milliliters. And let this boil for a few minutes. See if we can get any of the silver that might still be in there out of that gold. Well, the color sure does look different now after we boiled it in the hydrochloric acid. So now what we want to do is pour that acid off into our temporary waste container. Look at that, man. Nice caramel color now. That's what we want to see. And just pour this off into the temporary waste container. A little bit of gold might go over with it. That's quite all right. We'll get it out later on. Looks much better after that after that hydrochloric acid boil. And that's what we want to see, a nice reddish caramel color to the gold. That black color probably was some silver chloride in there. I'm going to add about 250 milliliters of hydrochloric. I'm going to add a few drops of sulfuric acid here just to precipitate out any lead. There probably shouldn't be any, but won't hurt a thing. I'm going to go with about, well, let's go. That was 8 3-milliliter shots for a total of 24 milliliters of nitric acid. I'm going to put this up on the heat and let this dissolve. That took about 20 minutes. I'm going to take it down off the heat now and let it cool down. And then we'll do another precipitation. I've got some ice cubes here made of distilled water. I'm going to add that into the solution now to get it to cool off. Here we go. We've got the solution cooled off with some distilled water ice cubes. Now what we'll do is pour it back through the filter. There shouldn't be a whole lot of trash in here by now. This is the second refining. Yeah, it's pulled through the filter in less than a minute because the solution is very clean. Just wanted to show you how clean this filter is. There's very little, there's zero solids in here. I've got the gold filtered. I'm going to set this out of the way now. I've got a scale up here, and what we're going to do is I'm going to measure out some iron sulfate, copperas, to precipitate the gold a second time. Copperas or iron sulfate is plant food. I've got about 2 troy ounces of pure gold in solution. That's 40 pennyweight, and the book tells me that I need about 1 pound of copperas per 50 pennyweight. So let's see if we can measure out about 450 grams of this iron sulfate to precipitate out the 2 troy ounces or 40 pennyweight of pure gold that I have in that solution. There we go. That's a pound of copperas. Now let's get set up to do this precipitation. What I'll do is use an extra large beaker, 4-liter beaker, to do the precipitation in. I'm going to use a 2-liter beaker to dissolve the copperas. Add a little distilled water here. It's about a half a liter. Turn on the stir bar. Now we're going to dissolve the copperas in this distilled water. I'm just going to start slowly adding it in. It's highly soluble in water, so it should dissolve fairly easily here. Add a little heat and keep adding the copperas until we get all this to go into solution. Let's get this beaker set up. I'm going to add a clean stir bar in here. Now we're going to pour our gold solution into this beaker. Here we go. Alright, we're going to stir this as we do the precipitation. I'm going to add a little bit more water here and then add some more of the ferrous sulfate. Let's get the rest of the ferrous sulfate in here now and get prepared to do the precipitation. I need to start doing this on every refining that I video. We'll get a little bit of the solution on a piece of filter paper here. And we're going to hit it with stannous, verify that we got gold in solution before we get started. It's important to do every time we do a refining batch. What this is a plastic lid with a hole cut in it. I just set it up on the beaker to support my funnel. And now what we're going to do, I've got hydrochloric acid. My ferrous sulfate solution is brown. I'm adding hydrochloric acid until it turns green. Here we go. There we go. We're all set up. Now what we'll do is add our ferrous sulfate solution to the funnel here. You got to filter this because it's got iron particles in it. So here we go. Notice that we've got some fumes in our reaction beaker over here. That means we had excess nitric in our gold solution. What's happening is the gold is redissolving just as fast as it precipitates.
Here's the entire precipitation and time lapse. It's really quite unremarkable. The benefits of using copperas is the copperas will drop only the gold. If other metals are present in the solution, they will stay in solution, and only the gold will precipitate. Here, I forgot to turn the sound on. I'm dipping a piece of filter paper in so we can do a Stannis test, and you'll see here that our Stannis test is negative, which indicates that all the gold has dropped out of the solution now. Here, I'm just going to remove the funnel, and we're going to get set up to do the rest of the process.
We're going to get rid of the waste solution out of here into this temporary waste container. It's full of gold waste, gold refining waste solutions. And here's a look at the gold. What we do now is just rinse this over and over until I get all the iron rinsed off of it. I'll rinse it with water and hydrochloric acid and get all the iron sulfate rinsed off of the gold. Let me get the stir bar up out of there. It's coated with gold. I just spray it off real good and try to get it to come loose off of there. Of course, it's not going to cooperate. Well, I've never seen this happen. The stir bar is caked with gold. I'm going to have to remove it with some aqua regia. Just continue to rinse this out. Get all the iron rinsed off of here. I'm going to give it a boil with some hydrochloric acid now. See if we can get the rest of the iron rinsed off. Just a splash of hydrochloric. And we're going to let that boil now. This is our third hydrochloric acid boil. The gold looks really good now, nice and clean. The solution is clear and colorless. Oh, we might have a little bit of color to it. I'm going to pour this off now. And I'm going to rinse it with some water multiple times. This is the final water rinse. We've got all of the color off of our liquid now. We've got all of the iron rinsed off of here. So what we're going to do is put it back down on the heat. I'm going to add some hydrochloric acid. Then we're going to put in a little bit of sulfuric acid. Now we're going to add some nitric acid and redissolve this a third time. we've got all the gold to dissolve. What I'm going to do now is, this is our stir bar encrusted with gold. What I'm going to do to get that off of there is add a little bit of hydrochloric acid to the beaker. And then we'll put some nitric acid in there with it. Form some aqua regia in there. This has been fully dissolved now for the third time. I'll put this down here, let it cool off. We're going to put our stir bar up here and let it heat up and dissolve off of there. Okay, we've got the solution filtered. It looks nice and clear. I'm going to set this aside. And what I want to do now, I'm going to do something a little different this time. I'm adding some distilled water to this beaker. Now what I'll do is dissolve some of this sodium metabisulfite in this distilled water. I'm going to set this solution now back out of the way, and I'm going to add the gold solution to this large beaker. I'm going to install a cover, put a funnel on top. Now we'll install a filter here. And I'm going to add the sodium metabisulfite solution to the gold solution. I'm going to see how this works. I've never done this before. Or it's been a long time. I have done this, but it's been a long time. Let's see what happens here. That's kind of weird looking. Now, if you look down at the bottom, you'll see a layer of pure gold powder forming on the very bottom of the beaker, and then it's got two other layers intermediate, like a parfait. Pretty sure all the gold has been precipitated now. I'm going to reach down in here, get some of this solution, on a piece of filter paper, and we're going to make sure that we've got everything precipitated now. You can see by that Stannis test, all the gold has been precipitated.
This is speeded up with time lapse. It's the entire sequence, and here at the end of this you'll see I can always tell when I have high purity gold when it settles out quickly like this and the solution sitting on top of the gold is colorless and crystal clear.
Alright, here's our pure gold powder. It looks real good. Notice the solution over the top of it is pretty much colorless. And the color of the powder is nice and caramel brown. That's what we want to see. So we're going to dump the waste solution into this temporary container here. Alrighty. Look at that stuff, man. That's our triple refined pure gold powder. I'm going to hit it with a little hydrochloric acid here. And we're going to give this several hydrochloric acid rinses. Try to get all the chemicals rinsed off of here. Rinsing real good, settling quickly. This is some high purity gold. I can just tell by looking at the way it's behaving in this beaker. I'm going to get this out of the way. I'll deal with this later on. This is going to be high purity gold in year 2. But I'll deal with this a little later on. What we're going to do now is put this pure gold powder up here on the heat and let it boil for a minute or two. It's been boiling in hydrochloric acid now for about 3 boils. I'm going to start pouring this off now and getting our pure gold powder. Man, it sure looks really, really good. The color is fantastic. This is going to be high purity gold powder. I'm adding some distilled water, and now I'm going to hit this with the blender and try to chop up all those chunks and get all the acid rinsed off of the gold. Here we go. It does an excellent job of breaking those chunks up. Oh yeah, look at that pure gold powder. Just looks delicious. Triple refined, high purity gold powder. Don't get no better than this. Alright, I've got some pH test strips here. I want to make sure I get all this acid rinsed off of here. You can see we're still down around pH of 1. I've been rinsing over and over with hot distilled water, and if you look here, we've got the pH pretty close to neutral now. I've got a container here. I've written the weight of the empty container aside, and what we'll do now is get our gold down into this container. What we're going to do is put it up on some heat now and dry this out. Trying to get all the water out of here that I can. Here I've got a dish that's got some water in it. I'm going to put this up on this heater back here, And I'm going to set my gold powder in this container in that water so that we can form like a steam bath and dry the gold powder off without having it spatter. Here's our gold powder. I've got an ice cold spoon here, and you can see that it's nice and dry now. That steam bath works real well. So what we'll do now is I'm going to pull this out of the water carefully, and we'll let that dry off, and then we'll get a weight on our powder. I've let the container dry off completely, and we've written the weight of the empty container on the outside. So let's see what we've got. We got 457.7 minus the empty weight, which is 399.7 equals. So we got 58 grams of high purity gold powder. This stuff is just gorgeous. It's nice. It's got the consistency of flour. And what we'll do then is, like I did before, we'll sell this gold powder by the gram on my eBay store. Alrighty, that will conclude the video. Thanks for watching.